person has learned English so well? He might live in England. Okay, one possibility. What else? Variables of other languages. I don't know what you mean. Probably he has had a good teacher. Yeah, one possibility. Could you repeat your question? Well, the question is, you are sitting in a classroom and one of your classmates speaks English like a native speaker, like a person from the US or from England. You look at the person and the person looks Iraqi, then you wonder why this English this well. What would you think of the possible reasons? Such as he may have had good English courses. Shima says got brilliant learning. Saad says he can imitate well. What else? Tables, I don't know what you mean. And classify them. Al-Musawi says technology. Musa says maybe his teaching staff is English or American. Yeah, possible. Shima says he wants to imitate. Ina says good evening. Okay, these guesses that you made are possibilities. Good pattern of the language. Well, these are all possibilities. In the context of research, when we come across a situation and we wonder why the situation is the way it is, and we try to come to an explanation, those explanations are called hypotheses. Okay, and that's why this session is about probability and hypothesis testing. So in addition to what you said with regard to the amazing fluency of a classmate in English, these are other hypotheses. Perhaps the person has a brilliant language learning aptitude or talent. These are actually the hypotheses which were formulated in my other class. So now imagine that we hypothesize that the person has a brilliant language learning aptitude. We attribute his success in learning, in acquiring fluency in English to his or her brilliant language learning aptitude. In that case, we are saying that success in language learning is mainly a matter of aptitude. Okay. Then we can form hypotheses about the relationship between aptitude as one variable and language learning as the other variable. Now we can state this hypothesis in different ways. We can say that there is probably there is a negative relationship between aptitude and language learning, which is not very intuitive, or we may speculate that, we may hypothesize that there is a positive relationship between aptitude and language learning success. So these are two possible speculations or hypotheses with regard to the relationship between language learning and aptitude. And if we say that there is no relationship between talent, language aptitude, and language learning, this is another kind of hypothesis which we call null hypothesis. Okay, so we have two types of hypotheses. We have null hypothesis and we have directional hypothesis. Let me just in front of you organize this this slide in a better way, so I can use this one. Okay, hierarchy. So I can use this one. Okay. So I'm going to tell you about hypotheses. So we have two types of hypotheses. We have a null hypothesis, and we have directional hypothesis. In a null hypothesis, we say that there is no relationship between, for example, aptitude and language learning. So I don't need this one, I can delete it. But in a directional hypothesis, we can say that there is a positive relationship between aptitude and language learning. So this is one possible directional hypothesis. Let's add another shape. Not here. Let's shape. Or we can say there is a negative relationship between aptitude and language learning. So as you can see, we have two types of hypotheses. One is a null hypothesis, and the other two are directional hypotheses. In the null hypothesis, where we hypothesize that there is no relationship between the two variables in question, and in the directional hypothesis, if we have evidence, then we may hypothesize that the relationship between aptitude and language learning is positive. What do we mean by positive? We mean that the more a person, the more aptitude a person has, the easier the person can learn a second or foreign language. And by negative relationship, which is another type of directional hypothesis, we mean that the more aptitude a person has, the more difficulty the problem has in language learning, which is not very plausible, because we think that most of us, I think most of you, agree that this is not a plausible hypothesis. So we are left with these two hypotheses, the null hypothesis and the positive directional hypotheses. So this was the an introduction to what a hypothesis is. In language learning, there are many problems, there are many questions for which there is no answer. And as a researcher, we usually begin with formulating hypotheses, and then we go about testing those hypotheses to see if they turn out to be true or if they turn out to be false. Okay. Any questions so far? I have no cake with chocolate. Unless we eat your food. Hiç ondan. So in with regard to I wonder if you hear me. Do you hear me? By aptitude I mean talent. Okay, great. So it seems that you have no questions. Zainab says, aptitude test your ability to perform tasks. Yeah, there are different tests of aptitude. Language aptitude is a special kind of aptitude, which is believed to be important for language learning. So in statistics, in addition to describing the data, we need to test hypotheses. And that's why, as I said before, we have two types of statistics. We have descriptive statistics, which is used when we want to describe a sample, and we don't want to extend the outcomes to similar samples. And by sample I mean a small group of people or animals or cases that you choose as a researcher, we choose to study. Because as a researcher, usually we can't study the entire population. For example, if you want to study the level of motivation among Iraqi students in secondary schools, definitely as a researcher you can't afford to study all the Iraqi students across all the Iraqi cities. So you have to limit yourself to a small sample of Iraqi students, and that group of students that you choose to study is called your sample. So sometimes the aim of the research is just to describe a sample, and we have no intention of extending the results of our study to similar samples. So in this case we use descriptive statistics. We only describe the sample that we have, and we don't want to generalize or extend the results to other similar samples. And sometimes we use inferential statistics, and this is the case when we want to generalize the findings that we find about a sample. We want to generalize to other cases, to the population, for example. So again, if you're, for example, studying the level of motivation among Iraqi students, you want to see how hungry Iraqi students are for learning languages, especially English. You want to see how motivated they are. Then, as a researcher, you can't cover the entire population of Iraqi students, so you choose a sample. Let me shut this door. So you choose a sample of students which you believe represent the wider population of Iraqi students. Do you hear me? Okay, thank you. And based on the sample, you want to generalize your findings to the population of Iraqi students. So you wanna make a claim about the level of motivation among Iraqi students across all Iraqi provinces and cities and schools. So in this case, we make use of inferential statistics. So what do these statistical tests do? Statistical tests tell us the probability that our results might be wrong. Okay, please remember that in research we always deal with probability, odds, chances, and likelihood, and these statistical tests tell us how much trust or confidence we can have in our inferences from the data. Okay, so it's a matter of trust or confidence, and we use the statistics to assess, to evaluate the degree of trust or confidence that we can have in the inferences that we make about the data that we gather from a sample. Now imagine that in the context of Iraq, you choose two schools. Okay, you choose two schools because that's what you can do, and in these two schools you measure the degree of motivation among students. And now you're going to make a claim about the level of motivation for language learning in the entire Iraq country. Now, how much trust or confidence do you think you can have in the inferences that you make about the level of motivation among Iraqi students based on your studying of these two schools? How much confidence do you think you can have in the results which are based on studying two schools in Iraq? Can you, for example, be 100%, 50% sure, 20%, 0%? No. No trust. Very. Okay, yeah. So it's difficult to say at this stage. It depends. It depends, and I can't give you an exact figure here because this is something which can be attained only through inferential statistics. So this was just a question to tell you that when we do a piece of research, the results are not always certain or definitive. Rather, we are always dealing with probabilities. And so that the degree of trust or confidence that we have in the findings of any research depend on the nature of research, the sample size, and many other issues. And the tool that we use to examine the degree of trust or confidence that we can have in research results are called inferential statistical tests. So we're talking about probability and how much trust or how much confidence we can have in the results. So this is a matter of probability, chances, or odds. And to tell you why it is important, you should be aware that science is almost always based on probability. That's why in science nothing is doubt proof, nothing is proved or certain. Everything is temporary, tentative, and nothing is proved forever. We may prove things in logic or mathematics, but in science, in hard sciences, in physics, in chemistry, in biology, in sociology, in language teaching, in applied linguistics, and in economics, in other fields, we never prove anything. Rather, we talk about probability. So we can speak of high, low, or moderate probability of an event or outcome. In our everyday life, we always deal with probability whenever we listen to the TV, we watch TV or listen to radio when they are telling us about weather forecasts. We want to see whether tomorrow will be raining, will be cloudy, will be stormy, windy, sunny, whatsoever. And sometimes I think you have this experience that the radio or television tells us that tomorrow we are going to have showers and it's going to be a heavy rain, and then you get up in the morning with the anticipation that it's going to rain, and then it turns out that it doesn't rain. Then we may accuse the TV of lying, but although the TV and radio stations sometimes lie, yet in the context of weather forecasts, sometimes they have no intention of lying. Rather, weather forecast is about probability. So based on the evidence that they have, based on the statistics that they have, they make a prediction that tomorrow will be, for example, raining, but it is probability, and probability is always subject to falsification. We may say that we are 90% sure that tomorrow will be raining, but in fact the other 10% may turn out to be true and it may not rain. So the weather forecast is a typical example of how research and prediction in human life is always based on probability. The other example is the drugs or the vaccines which are being made for treating COVID-19. So they will never, the scientists who are working hard to invent such a vaccine or drug, they are never 100% sure that this vaccine or the other one is going to be effective 100% for everybody. Rather, all their experiments are based on probabilities. They may, for example, say that this vaccine is 80% effective. So if you take it, if you get vaccinated, you have 80% chance of being immune from COVID, and there is 20% chance that the vaccine has no effect on the virus. And this is true of other vaccines too. And this is the nature of human knowledge. Our knowledge is always based on probability, and that's why uncertainty is a constant feature of knowledge. Knowledge is never certain. And just for your information, there are two schools of probability thought. One is frequentist probability school, and the other one is Bayesian. Beyond this dichotomy, you don't need to worry about how these two schools differ from each other. This is a definition of probability. Probability is the proportion of times that any particular outcome would happen if the research were repeated an infinite number of times. So if you, for example, do a piece of research, you want to see to what extent you can trust the findings. And the probability here means that the number of times, or the proportion of times, that each time you do the experiment, you would come to the same results or findings. Again, back to the example of motivation in the context of Iraq, probability here is about the proportion of times that you will come to the same finding about motivation among Iraqi students if you could repeat your research an infinite number of times. For example, if you could do the experiment 100 times and 95 or 99 times you come to the conclusion that Iraqi students are highly motivated for English learning, then you can claim that the probability of my findings being true is 99%. This is a high degree of confidence because there is only 1% chance of being wrong about the level of motivation among Iraqi students. And hypotheses are in fact educational guesses. Sorry, this should be educated guesses. Educated guesses about the probability of something being true. So as you can see, the terms hypotheses and the terms probability are closely related. Okay, so hypotheses are educated guesses. And by educated, I mean not wild guesses, not wild guesses. I mean, an educated guess is a guess which is based on some logic, some reasoning, some previous knowledge or common sense. But a wild guess is just wild. It is not based on any evidence. So a hypothesis is an educated guess about the probability of something being true. And I told you about the null hypothesis. Let me go back to the null hypothesis. So we said that the null hypothesis is that there is no relationship between the two variables which we are studying. And if we can reject the null hypothesis, we want the probability to be very low that we are wrong. If, on the other hand, we must accept the null hypothesis, again, we want the probability to be wrong very low. You might wonder why do we need a null hypothesis? I guess you might have heard about the discourse of legal system in Western countries. In Western countries, the court system always begins with a null hypothesis. What does it mean? So imagine that you are accused of stealing, okay, and you are taken to the court in, for example, in Canada. Now, to be fair, the judge or the jury, they do not begin with the assumption that you are the stealer, that you did the stealing. Rather, they would start with a null hypothesis. Okay. Let's accuse you of a more serious crime. You are accused of bank robbery. Okay, you rob a bank, you are accused of this, then you are taken to a court in Canada, and they will begin with a null hypothesis, and the null hypothesis is that there is no relationship between robbing that bank and you. In other words, we can simplify this null hypothesis and say that you didn't, the judge begins with this assumption that you did not rob the bank. This is a null hypothesis. They begin with this and they try to reject this null hypothesis. If they can reject this null hypothesis, and if they can reject it with a high degree of confidence or with high probability, then they can gradually be convinced that the person who robbed the bank is in fact you. Okay? Now, imagine that the court begins with this hypothesis, with a directional hypothesis, that you did rob the bank. If the judge begins with this assumption, then it is very easy to prove you guilty. So even a small piece of evidence would be enough to say that you are the person who robbed the bank, and therefore it is not an accusation, it is in fact a reality. So as a researcher, we don't want to be biased. And that's why we begin with a null hypothesis. So to counter against the bias, to prevent bias from influencing our results, our research results, we begin with a null hypothesis. We try to reject the null hypothesis, and we try to reject it with a high degree of confidence. So back to our original null hypothesis. We said that there is no relationship between talent or aptitude and language learning. So this is a null hypothesis. As a researcher, we like to see a relationship between these two variables, between aptitude and language learning. But we begin with a null hypothesis because if we begin with a directional hypothesis, it may show that we are biased towards a specific direction. So we begin with a null hypothesis and we try to reject this null hypothesis. If we reject this null hypothesis and we reject it with a high probability, then we would have enough evidence to go for a directional hypothesis. Is it clear? Okay. Zainab says, so hypotheses are based on insufficient evidence. Yeah, quite. Shima says, what is the benefit of this hypothesis? I don't know which hypothesis you had in mind when you typed this question, Shima? Yeah, and Musavi. So you have asked many questions. Mona says, hypothesis testing the basic question, how sure that we are right, or how sure are we that we are wrong? Matt says, in null hypothesis testing, this criterion is called alpha and is almost always set to if there is less than 5 chance of a result. Yeah, quite true. Yeah, right. I agree. Clear. Some says, do we always start with null hypothesis? Not necessarily. This is a good question. If we have no evidence, null hypothesis, we begin with directional, with a null hypothesis. However, if we have some evidence, or if logic or theory or previous research tells us null hypothesis may be correct, then we'll go for a directional yeah, right. Okay, let's go a bit further. Some says so directional hypothesis because there is evidence. Yeah. Now, when we formulate our hypotheses, whether null or directional, then we need to test our hypotheses. And to test our hypotheses, we do statistical tests. And such tests are almost always dependent on the concept of normal distribution, if you remember. What is a normal distribution? This is a definition. For any human activity, if we continue to collect data from more and more subjects or events, we will approach a normal distribution. It is possible then to locate the data of one student or event in the distribution and talk about how typical or how probable, so probability, how probable it is in the total normal distribution. Do you remember the concept of normal distribution? Do you remember it? My question, yes, Sarmat says it is often called the bell curve. Yeah. The question was, do you remember the concept of normal distribution? If you have, just to remind you, remind those of you who might have forgotten distribution. Let me just show it to you. So let's Google the term together. Normal distribution. Just Google this and look at the images. Well, do you see this internet page? Okay. So these are examples of normal distributions, as you can see. Well, the common feature of all of these pictures is that they are symmetrical. And the shape of the distribution is like a bell. I'm not sure if you have seen such bells. So these are all normal distributions. This center here, this is the mean of the distribution. So let's look at this one from a closer distance. So this spot, this here, this is the mean of the distribution, and half of the cases fall to the right side of the mean. So this is the mean. Half of the scores, half of the data fall on the right side, and the other half of the scores fall on the left side here. And between 1 SD or 1 standard deviation above the mean and 1 SD below the mean, we have 68% of the data or the scores. So if I have explained this in the previous sessions, so I don't need to repeat it. Let's go to the table of z-scores. So the z-score is based on the concept of normal distribution. And for example, when we say that a score, the z-score is 1. And so the z-score is in fact a ruler in which the unit of measurement is standard deviation. So let me type this one for you. So z-scores, we can z-score is a ruler whose unit of measurement is standard deviation. What is the unit of measurement in the rulers that we usually use? You don't see the pictures, you don't see the slides. Okay. Yeah, Osam says centimeters, right. So usually the rulers that we use on the rulers that we use, the unit of measurement is centimeter. Or now we have a ruler whose unit of measurement is the standard deviation. Such a ruler is called the z-score. So the z-score, just like a ruler, does not always fall on a certain round standard deviation. It may fall on any point on the x-axis. Thus, there has to be a mechanism for calculating the z-score of any score. If you don't remember how we calculate z-score, this was the formula, that the z-score is in fact the SD, provided that the definition is normal. The ST equals x minus mean divided by standard deviation. This would be the z-score. Sorry, this should be z. Okay. To give you an example, suppose that you took a grammar test. You took a test of TOEFL, and you got a score of, for example, 70. And the mean score, the average score on the test, I mean the average score of all the test takers on this TOEFL test was, for example, 60. Okay, and the SD, the standard deviation on this test was, for example, 5. And because there were thousands of test takers who took this TOEFL test, we can suppose that the distribution of the scores was normal. Now we want to calculate computer z-score. So your z-score, z-score equals your score. What is your score? 70 minus mean. The mean is 60, and divided by standard deviation is 5. So it would be 10 divided by 5. It would be 2. So your z-score is 2. Now, should you be happy for this z-score, or should you be sad? Well, we can answer this question by looking at the normal distribution to see whether this is a good z-score or a bad z-score. So let me show you the normal distribution again. So this is the mean. This is one standard deviation. This is z-score 1. This is the z-score of 2. When your z-score is 2, it means that you outperform, or you got a score better than all the people whose scores fell in this area, okay? And only this red part got scores better than you. In other words, only 3% of participants got scores higher than your score. Or, in other words, you got a score which is higher than 97% of all the test takers on TOEFL. So this z-score shows that the probability of obtaining such a score on TOEFL is very low. That only 3% of people are likely to get such a score, and therefore, if your null hypothesis is that your score was just average, then you can reject the null hypothesis with high confidence, because the score you obtained is a very high score, and there is a very low probability that you obtained this score only because of chance. So the concept of probability and the concept of z-scores are closely related. If you obtain a result which falls within this green area, it means that because these two green areas are around the mean, it means that that score is average, it is typical. And in a normal distribution, most people would obtain such results. Therefore, what you obtain is not out of normal. It is very likely, it is typical, it is likely. Okay? But in hypothesis testing, we want to obtain a score with a high probability. Okay? And the more the score that we obtain, the closer it is to the right tail of the distribution, the more confidence we have that this score has not occurred because of chance. That's it. So I think it's better to, this is a table of z-score. Whenever we have a z-score, we can refer to this table and see the probability of that z-score. When the z-score is round, 1, 2, 3, it's easy to locate it on the normal distribution, but most of the time the z-score is not a round score, and therefore refer to the table of z-scores. This is a practice for you. I guess I should give you time to do this practice. So do the practice for next no picture again. Okay. Yeah, do this practice and other practices in the same chapter from which, yeah, this is an assignment. Okay, so for next time, do the assignments in this chapter, chapter 8, and to see this chapter is from which book, go to the syllabus, is from H.N. Lazartan. Do all the practices in the same chapter and submit your assignments using this LMS. Assam says, what? Oh, I don't know what you mean, Assam. And also, for next time, be ready for your final exam, okay? So your final exam will be next Saturday. The same time. The final exam is based on the syllabus. The questions will be multiple choice and open-ended. Oh my God, open-ended, it means that you would need to explain, write the answer. I said the questions are either multiple choice or open-ended. You can Google multiple choice and open-ended. So thank you very much for your attendance. Take care and have a good time.